In this video, I'm going to be covering the java.util.collections class. It's important to understand that this collections class is not the collections framework. The framework contains many interfaces and implemented classes, as well as helper classes, for which this collections class is just one example. At one time, Java had interfaces, but no support for static or default methods on them, so useful methods were packaged in these helper classes. Some of these methods have since been implemented on the interfaces themselves, but there's still some functionality on the collections class you might find useful. I'll examine some of these in code and compare them to the methods on the interfaces now available. In the last video, I created some code I'll be using in this video, and a couple of the ones that follow. I'll briefly discuss it here for those of you who decided to skip that walkthrough. This code has card, a record with a nested enum called suit, declared in it. Suit is either a club, diamond, heart, or spade, and this enum has a helper function, getImage, that returns a printable character value for that suit. I overrode the toString method on card to print that character along with what I call the face or face value of the card, so 2 through 10, or jack, queen, king, or ace. Each card will also have a rank, starting with 0 for the lowest card. In a standard deck, the lowest card, a 2, is 0 because an ace is usually the highest value card, though an ace can represent a 1 sometimes. The card has static helper functions I'll be using in the code in this video, one to get an instance of a numeric card, and one to get an instance of a face card. In addition, I can get a list of cards that represents a standard deck of cards. There's also functions to print the deck of cards. Okay, so getting back to the main class in the collections methods project, you can see I have 2 lines of code there from the previous video. I have a list of cards I'm calling deck, and I get that by calling a static method on the card class called getStandardDeck. Then I simply call the printDeck, another static method on card, to print the cards in my deck. I'll run this code. That gives me 52 cards in 4 suits, starting with 2 through 10, then jack, queen, king, and ace. 2 has the lowest rank, the number in parentheses, so 0, and ace has the highest rank, so 12. This setup will give us lots of opportunity to test out the many methods on java.util.collections. I want to start out by exploring some of the methods on collections for populating a list. Before I start, I'll first use a method I've shown you before on the arrays helper class called fill to fill an array. I'm going to create an array of cards just for one suit to start out, so I'll create an empty array of 13 cards. I'll generate an ace of hearts card using the static getFaceCard method on my card record, passing card.suit.heart, then the character capital A. The thing to note here is that suit is a nested enum inside of card, so for me to access it from this main class, I have to use the card type as a qualifier to the enum type name suit. Next, I'll call the fill method on the arrays class, passing the ace of hearts card. I'll then print it out, passing my array as a list backed by an array. I'll call the overloaded version of printDeck so I can pass a description, and I just want that printed out in a single row. Let's see if that all works. You can see the output. I have an array of 13 cards, all filled with the same kind of card, an ace of hearts, and aces have a rank of 12. It looks good so far. By the way, I'm reviewing this method on arrays because I wanted to also show you that the collections class has a fill method that seems to be very similar, so I want to look at that in comparison. That method takes a list and an element. I'll create a new array list of cards, just calling it cards, and specify that it can hold 52 cards, which of course is the number of cards in a standard deck. I'll call fill from the collections class this time and pass it my cards list as well as the ace of hearts card. I'll print the list simply by passing it to println this time, and I'll print the size of the list. This method on the collections class looks a lot like arrays.fill, so you'd expect to get an array of 52 cards back, all aces of hearts. Let's see what happens when I run it. That shows that's not what happens. Instead, the list is empty and the size of the list is 0. When I initialize the array list, passing it 52, it just sets the capacity to 52. It doesn't populate the list with elements. Unlike an array, the list isn't populated with 52 null references, for example. Using fill here from the collections class would fill the list if its size were greater than 0, meaning it would replace every element with the element passed to the method. The fill method doesn't actually add elements, so if my list is empty, it stays empty. How can I fill this list with some default value? Fortunately, the collections class offers us some alternatives. One of these methods is called endCopies, which creates a new list with the number of elements you specify as the first argument, filling it with the element you pass as the second argument. First, I'll set up another local variable and call it aces of hearts, and assign that to the call to collections.endCopies, passing 13, and the card I created earlier, the ace of hearts. And I'll use card.printDec, so I get a line separator and a header, but I'll print these cards in a single row. Like the array fill example, I now have 13 aces of hearts in this new list. I'm going to copy those last two lines and paste a copy directly below that. Before I change anything, I want to first add a new card before these two statements. I want to create a king of clubs, so I'll call card.getFaceCard, passing it card.suit.club and the character K. Now I'll change the list name from aces of hearts to kings of clubs on the first line. I'll change the card passed to endCopies on the second statement, from ace of hearts to king of clubs. Finally, I'll change the call to printDec, again replacing aces of hearts with kings of clubs, and also specifying kings of clubs as the descriptive header. Okay, running that now. I have a second list with just kings of clubs. Next, I want to populate my full deck with some of these. Like list, the collections class includes an add-all method. Its first argument is the list I want to add elements to. The second argument is for the elements to be added, but unlike list's add-all method, this is a variable argument of elements to be added. The difference is that list's add-all method takes a collection of elements to be added. Let me show you this method. Remember, my cards list is still empty, with an initial capacity of 52 cards. I'll call collections.addAll, passing it my cards list, and I'll just simply pass my card array of aces of hearts to that. And then I'll print out the cards deck. Running this code now. You can see that my cards list now has the same cards as the aces of hearts list. For good measure, what do you think happens if I just execute add-all on cards, passing it this array? Let me add that code right after the collections.addAll method. This code doesn't compile because you can't pass an array to the add-all method on list. You can pass a collection or another list, which is why you'll often see me using list.of or array.asList as part of that method. I'll remove that last line. Next, I want to examine the copy method on java.util.collections. First, I'll comment out the last two statements in my main method, which added elements to the cards list. I'll next make a call to collections.copy, passing it my now empty cards list and the kings of clubs list, which had 13 king of clubs cards in it, and then I'll print that out by calling printDec. The copy method on collections takes two arguments. The first is the destination of the copied elements, and here I'm passing my cards list, which I want to be my full deck. The second argument is the elements to be copied, and I'm passing the kings of clubs list. You'd expect this to copy the elements in kings of clubs to cards, so let me run this. You can see I've got an error, source does not fit in dest. This is similar to the problem I had earlier with the fill method on collections. My card list is empty. Remember I commented out the add-all method, so nothing has filled or populated or added elements yet to my card deck, so its size is still 0. You can't use this copy method if the number of elements in your current list is less than the number of elements in the source list. I'll uncomment out those two lines of code above, so cards will have the 13 aces of hearts in it before I use the copy method. And now running that code, you can see my aces in the card list were replaced with kings. What happens if my destination has more elements than the source? Let's add some more cards. I'm just going to copy that add-all statement, pasting a copy right below it, so that we get 26 aces added. I'm also going to change the call to printDec to print on 2 rows, so it's easier to read the output. And running this, you can see it only copied over 13 elements, replacing the first 13 aces with kings. What I want you to understand here is that this method copies elements from one list to another. It doesn't return a copy of your list. elements are being assigned to the existing destination list versus a copy of the list being made. If you want a full list copy, you'd use the list.copyOf method, so let me revisit that method. I'll reassign cards to the result of list.copyOf, passing it my kings of clubs list. And I'll print my cards list in a single row. This gives us the result, which is the same as the list kings of clubs. This method is a true copy, though it's important to remember that this method returns an unmodifiable list. If you needed a modifiable copy of the list, you'd make a call to the copyOf method and pass it to a list constructor, or use add all, for example. Okay, so in this video we've covered the fill method and compared it to the fill method on the arrays helper class. I've shown you how to use nCopies and the difference between the add all methods on collections. I've also compared the collections.copy method with lists.copyOf method. The first copies elements, replacing existing elements with the elements passed. Lists.copyOf method returns an immutable copy of the list passed. In general, if there's some overlap, like add all on list, you'll want to use the methods on the interface types and not the helper methods on the collections class. Java has updated many of the methods on the collections class to simply defer to the interface methods in many circumstances. In the next video, I'll continue with the discussion of functionality supported on this collections class. See you in the next video.